Rowe's approach uses PMU measurements to create state estimator cases at PMU sampling rate. There are 3 PMUs which stream data at 30 samples per second. Using PMU data, Rowe creates 30 10-bus state estimator cases each second. No equivalencing is done. The algorithm is based on linear state estimation. Starting from buses where measurements are available, we compute flows and voltages at those buses, which are connected to the buses with PMUs. Then we compute values of generation and loads and positions of switch shunt. Voltage stability case 1 is fully observable using PMU measurements. Rowe's solver plots graphs of voltage magnitude at bus 301 and real and reactive power flows on transformer 301-304 as obtained from PMU stream. We now plot the same values computed from the state estimator cases created by Rowe. PMU measurements and state estimations are very close. At about 245 seconds, we observe voltage at bus 301 dropping below 0.97 per unit for 3 seconds, which results in shunt capacitor switching. Voltage stability assessment is performed 30 times per second using PMU-based 10-bus state estimator cases created by Rowe's linear state estimator and solved by the Newton method. Operator display shows real-time visualization of power system conditions. We analyzed 3 scenarios for voltage stability case 1. In scenario 1, we are ramping wind and scaling load using 50-50 pickup between load buses 102 and 202. We compute megawatt margin while simulating additional wind output. In scenario 2, we simulate additional transfer from north to south by increasing generation at bus 100 and decreasing generation at bus 200. We compute megawatt margin while simulating additional transfer for current value of wind. In scenario 3, we compute reactive power margin by scaling reactive power of loads 102 and 202. We compute megavar margin at system loads. In each scenario, we stress the system until voltage violation and voltage collapse and build 2 boundaries. Megawatt-megavar limit is the smallest of the 2 numbers, security limit and stability limit. Margin is the difference between the limit and the actual base case value. Rowe identifies 4 system states: secure operation, alert, alarm, and severe alarm. Severe alarm is issued when violation occurs on the base case. Alarm is issued if margin is less than 5% of the limit. Alert is issued if margin is less than 10% of the limit. Secure operation means that margin exceeds alert threshold. For all scenarios, alerts and alarms are due to approaching security boundary. Severe alarms are issued for all scenarios starting at 304 seconds. For scenario 1, alerts and alarms are mostly from 295 to 340 seconds. For scenario 2, there are alerts and alarms starting at about 241 seconds and going on and off until 560 seconds. For scenario 3, we see margins decreasing at 245 seconds before shunt cap switching. Margins are also small after 300 seconds. We issue only severe alarms for this scenario. Clicking on a bus on the one-line diagram plots PV curves. It also plots VQ curves and computes sensitivities for the selected bus. Clicking on the bus also invokes plotting of trends for the selected parameters.